Welcome back. We are still discussing the unit circle and trigonometric functions. Here in part 2, we are going to be discussing values of the sine and cosine function in quadrant 1. Whether you are taking pre-calculus, trigonometry, calculus, whatever it may be, you are going to need to know a handful of specific values of cosine and sine, and those are what we are going to discuss here. Some of them you can kind of think your way through. Others of them, frankly, you do kind of just have to memorize, although we will discuss a strategy that I learned that has been super helpful for me. Maybe it will be helpful for you. In any case, let's get going. We're going to focus on the first quadrant in this video. So the coordinate plane divided up into 4 quadrants. The first quadrant is this quadrant up here, top right, where both x and y are positive. Depending on who you talk to, the axes may or may not be included in the quadrants themselves. In this video, we're going to include those axes. So we are going to talk about these points up here and here. And I just want to focus on these in this video because it turns out, as we'll see in a future video, if you know the values of sine and cosine at these values, then you can do the entire unit circle, all the trig functions, using what you know about the first quadrant and sine and cosine. Just as a quick recap from last time, recall that that sine of theta, so if we're given an angle theta, sine of theta is defined to be the y-coordinate of the point on the unit circle at theta radians. So for example, sine of pi over 3, we would look at this point here on the unit circle, and we would look at the y-coordinate. And that y-coordinate would, by definition, be sine of theta, sine of, in this case, pi over 3. Similarly, cosine of pi over 3 is just the x-coordinate of this point. Okay. I've made us a nice little table down here with sine and cosine. We're going to go ahead and fill it in. These are going to be the angles in the first quadrant that I think in just about any of those classes that I named, you are probably going to have to memorize. Depending on your instructor, you may or may not need to memorize them. But in general, as a good rule of thumb, you should definitely know these specific angles. Angle 0, pi over 6, pi over 4, pi over 3, and pi over 2. I'm going to work in radians throughout this video and future videos. In most calculus classes, I think that's the norm, although you should still be able to go back and forth because you will sometimes work with degrees, but generally speaking, radians is kind of the standard, at least in my experience. With that said, let's look at these guys. So let's start with let's start with sine and cosine of 0. So remember, to find these guys, we start at this point 1, 0. We always start at the point 1, 0, and we move counterclockwise 0 radians. So we're actually just staying right here. Now, so we're here at this point 1, 0. Remember that sine of 0 is just going to be the y-coordinate of this point at the angle 0, right? We already know that this is the point 1, 0. So pretty quickly we see, oh, okay, so sine of 0 is just going to be 0. Now I'm going to write some things a little bit funny in this video. You can ignore the funny ones for now. We'll come back to them later, right? Technically, this isn't wrong. The square root of 0 is 0, and 0 divided by 2 is 0. But you can ignore this for the time being, okay? We'll come back to it later. I promise it'll make sense. But sine of 0 is 0, as we just saw. Similarly, cosine of 0 is just the x-coordinate here, which we can see is 1. Okay, so that one you can kind of just think your way through. If you remember where you are in the unit circle, then you can figure out what the x and y coordinates are and go from there. I'm also going to write this cosine in kind of a funny looking way. I'm going to write 1 as the square root of 4 over 2. Square root of 4 is 2. So that's 2 over 2, which is 1. Again, you can ignore the silly things for now. We'll come back to those later. For now, hopefully you are on board with the fact that sine of 0 is 0 and cosine of 0 is 1. Before we get to these intermediate angles, let's actually go ahead and jump up to the top and look at this point here when our angle is pi over 2, because I think this one will be a little bit easier than the others. In fact, it's quite similar to 0. So if our angle is pi over 2, that's a 90-degree angle. So we started here at the point 1, 0, and we rotated 90 degrees, or pi over 2 radians, and that brought us right up here to the top of the circle. Since our unit circle has radius 1, that means that we're at the point 0, 1. So just like we did a moment ago, we can fairly quickly conclude what sine and cosine are at pi over 2. So for example, sine of pi over 2 is just the y-coordinate here, which is 1. So this is part of why taking some time to understand conceptually what's going on can be really valuable. You could just memorize these things, but for me, it saves me a little bit of brain space, a little bit of storage up here to just remember how to kind of derive these things when I need them on the spot. I'm going to write another silly thing. I'm again going to write 1 as the square root of 4 over 2. And again, you should ignore that for now. Similarly, cosine at pi over 2 is just the x-coordinate at this point up here, which is 0. So I'm going to write that down, write down something a little bit silly along with it. Okay. So that takes care of 0 and pi over 2. Now we have these intermediate guys remaining. These are the three that you're almost certainly going to have to know for your calculus class or whatever class you may be taking. Pi over 6, pi over 4, and pi over 3. Okay, I've also written the corresponding degrees here as well. These, unfortunately, you can't do much more than just memorize their values. You can, as we'll talk through in a minute, you can kind of reason your way through it somewhat, but at the end of the day, some memorization is required. So I'm going to go ahead and just write them down, starting with sine of pi over 6. Sine of pi over 6 comes out to be 1/2. And again, I'm going to write something silly, which you should ignore for the time being. Cosine, it comes out to square root of 3 over 2, which I'm actually just going to leave that. That's already written kind of similar. It's already kind of in the same format as the other ones that I've written. So I'm actually just going to leave that one like that. At pi over 4, both sine and cosine are equal to one another, and they are equal to root 2 over 2. Okay. Notice that this kind of makes sense, by the way, if you think kind of intuitively. So pi over 4, that's 45 degrees. So that's right in the middle of this. That's right from here to here, that's 90 degrees. And we've just cut it in half. So it kind of makes sense that the x and y should line up. They should agree there. They were right in the middle, kind of these guys. Okay. That's just an intuitive explanation, but hopefully that makes some sense. It's helpful for me to think about at least. Finally, for pi over 3, turns out that sine here is root 3 over 2. Cosine here is 1/2, which I'm going to write as kind of a funny looking thing, root 1 over 2. Okay. So to some extent, like I said, you can't really, I'm sure you could figure these things out if you were super clever, but these 1/2, root 3 over 2, root 2 over 2, to some extent, you kind of just have to remember these values. They don't fall out as nicely as the zeros and ones that we saw. However, there are a couple of strategies that I want to discuss now to help you remember these things. At this point, I want us to finally take a look at the silly looking things that I've written here. Okay, let's start in the top row. You'll notice, I was showing this to a student the other day, and she just lit up whenever she saw it. Notice that these guys are all very similar. All that's happening is the thing under the radical on top is going up by 1 each time. Right? If the things I'm circling here are just 0, 1, 2, 3, 4. So that's one way that you can kind of remember what's going on here. They always have this, whenever you write them in the funny way, they always have this over 2. And then on top, it's root 0, root 1, root 2, root 3, root 4 as you go up, right? So for sine, we're starting here at 0 over 2. Right? Sine of 0 is 0, as we just saw. And then as we go up, okay, now it's root 1 over 2, which is just 1/2. Now it's root 2 over 2, root 3 over 2, and root 4 over 2, which is just 1. Now, to answer a question that student the other day asked me, if you are writing this in your class, please, for your instructor, please on your paper write 1/2. Don't write root 1 over 2. Technically, root 1 over 2 isn't wrong, but 1/2 is obviously simpler, right? So you should write down the simplified versions, the things that the silly looking things that I've written here, right? These are just to help you remember. Now, root 2 over 2 and root 3 over 2, you can't really write those more simply. So those you would write that way. But the others you should write the nicer way. This is just a cute little trick. It works the same way for cosine, except it goes in the opposite direction, right? For cosine, we're starting at 1, and then we're moving down to 0, which makes sense. Cosine here is 1, and then because cosine is our x values, since we're moving to the left, the x values are getting smaller. So cosine, it's the exact same values, it just moves in the opposite direction, which is kind of nice. Now, let's think, so how do you remember which one is which? We can actually take this one step further even. So whenever I see sine of pi over 6, for example, how do I work through that? How do I come to the conclusion that it's 1/2? Well, first of all, I remember, as we said a moment ago, that at pi over 4, sine and cosine are equal to one another, right? So that is a fact that I've remembered. Again, it makes sense to me because pi over 4 is right in the middle of 0 and pi over 2. So it makes sense intuitively that they should agree there, that x and y would be the same. Okay. So if let's say that I was asked to find sine of pi over 6. Well, I look at my unit circle and I think to myself, okay, pi over 6. First, let me sketch. So this is pi over 4. And at this point, I know that sine is equal to cosine. Right? As we just said a moment ago, I've remembered that. So in other words, the x value is equal to the y value. Now, pi over 6, so this is what goes through my mind. Now I think, okay, pi over 6, if I think about that one, pi over 6 is smaller than pi over 4. So that means that I haven't quite gotten up to pi over 4 yet. So I'm somewhere below pi over 4. I'm somewhere below and to the right of pi over 4. So that tells me, so I'm below and to the right of pi over 4. Well, since x and y are equal at pi over 4, and I went down and to the right, I conclude, oh, x must be greater than y here, right? Cosine of pi over 6 must be greater than sine of pi over 6. Again, x and y were the same here, but then I went down and to the right. So now x has gotten bigger, y has gotten smaller. So I know in my brain, I say, okay, I know that sine of pi over 6 is either root 3 over 2 or 1/2. And then I remember, right, sine is going to be the smaller one here. So that is what allows me to remember, ultimately, that sine of pi over 6 is 1/2. It is the smaller of the two. That's how I remember it. That may or may not be helpful to you. As with so many other things in math, if that makes no sense to you, flush it down the drain. Find something that does make sense to you. As long as you have some way of thinking about it that makes sense to you, you're going to be in good shape. That's how I remember it. That's been super helpful for me, so maybe it will be helpful for you as well. Regardless of how you do it, you definitely need to memorize your unit circle. The best thing I can recommend is practice, practice, practice. There's a great unit circle game online. If you just search unit circle game, it will come up. This is a great way to help you practice as well. Anyways, thanks for watching this video. I hope that you have found it to be helpful. In the next video, we'll talk about the other trig functions, tangent, cotangent, secant, and cosecant, which are all built out of sine and cosine. After that, the next video will discuss reference angles, where you can extend what we've learned here about the first quadrant to all 4 quadrants of the unit circle. And then I think in the last video, we will discuss the inverse trig functions. Anyways, thanks for watching. Hope you found it helpful, and I will see you in the next video.